Hello everyone, welcome to my channel on engineering mathematics. This video is about concept overview and examples on Bayes theorem. Let us first see what you will learn from this video. First we see what is partition of sample space. Then we see theorem of total probability. Next we will learn Bayes theorem, and then finally we will solve examples based on Bayes theorem. So let us proceed with partition of sample space. Partition of sample space is the collection of events, say A1, A2, A3 up to AN, such that union of all these AIs is the entire sample space. All events AIs are disjoint. That means intersection of AI and AJ, where I is not equal to J, is always empty. And finally, all AIs should be non-empty for all I. Let us understand these axioms using this Venn diagram. This is entire sample space. This sample space consists of events A1 to A7. Clearly, union of all these events is the entire sample space. So this fulfills our first axiom. Also note that none of the event is intersecting to other event. That means AI intersection AJ is always empty for any I comma j. Also, none of the event is empty. That is, AI is not equal to empty for any I. Therefore, this A1 to A7 partition sample space is. I hope guys you understood this concept of partition of sample space. Now note that if B is any event within S such that B is union of subsets, say B intersection A1, B intersection A2 up to B intersection AN, then this B can be shown in this way in this sample space. You can see that B is any or some event in S such that it is intersecting the other events. Then B can be expressed as B intersection A1 union B intersection A2 union up to B intersection AN. Now let us proceed for theorem of total probability. We will consider any event B from sample space S such that B is union of subsets B intersection A1, B intersection A2 up to B intersection AN. As we have seen, these events B intersection A1, B intersection A2 up to B intersection AN are mutually exclusive. Using addition law of probability, we can write probability of B as probability of B intersection A1 plus probability of B intersection A2 plus up to probability of B intersection AN. Using conditional probability, we know that probability of B intersection any event AI is always equal to probability of B by AI into probability of AI. So we can replace all these probabilities of B intersection AIs with this to get probability of B as probability of B by A1 into probability of A1 plus probability of B by A2 into probability of A2 up to probability of B by AN into probability of AN. Altogether, we can write this in summation format as probability of B is equal to summation of probability of B by AI into probability of AI, where I varies from 1 to n. This is theorem of total probability. I hope guys you understood this theorem. Now let us proceed for Bayes theorem. For that, consider events A and B. Then by conditional probability statement, we can write probability of A by B as probability of A intersection B upon probability of B. Then by theorem of total probability, we can write P of B as P of B by A1 into P of A1 plus P of B by A2 into P of A2 up to P of B by AN into P of AN. Now recursively using conditional probability statement for probability of A intersection B, we can write P of A intersection B in the numerator as P of B by A into P of A. So we get P of A by B as P of B by A into P of A upon P of B by A1 into P of A1 plus P of B by A2 into P of A2 up to P of B by AN into P of AN. And since this statement is true for any event A, we can write this statement for particular event AI as follows. So we get P of AI by B as P of B by AI into P of AI upon P of B by A1 into P of A1 plus P of B by A2 into P of A2 up to P of B by AN into P of AN, where this term in the numerator will be one of the term of the denominator. This is Bayes' theorem. I hope guys you understood this theorem. Now we will see some examples based on this theorem. So let us proceed for our first example. Let me read out this question for you. In class 12, 4% of boys are over 6 feet tall and 1% of girls are over 6 feet tall. The total student population is divided in the ratio 3:2 in favor of girls. If student is selected at random from among all these over 6 feet tall, what is the probability that the student selected is a girl? Let us see solution. Let us first understand this example. Here, experiment is to select a student from a certain class. Then clearly, we have only two choices for selection. Student will be either boy or girl. So this sample space is divided into two parts, B and G, B for boys and G for girls. Since it is given that if a student is selected at random from among all those over 6 feet tall, so we will have this event T which will intersect the partition B as well as G. So to find the probability that the student is a girl, we have to find the probability of G by T. This can be done using Bayes' theorem. So let us write this solution in formal way. First, we note down the required events. Since we have to find the probability that the student selected is a girl, we will define events, say B and G, such that event B denotes student selected is a boy and G denotes student selected is a girl. Note that B and G both partition the sample space, because in the experiment of selecting a student, we have no other choice than boy or a girl student. Therefore, B and G events partition the sample space. Now we define event T, which denotes the student is over 6 feet tall. Given that the student population is divided in the ratio 3:2 in the favor of girls, it means that out of 3 plus 2, that is 5 students, 3 are girls and 2 are boys. Therefore, probability that the student selected is a boy is 2 out of 5, and probability that the student selected is a girl is 3 out of 5. Also given that there are 4% of the boys over 6 feet tall and 1% of the girls are over 6 feet tall. Therefore, the probability of T by B, that is the student selected is over 6 feet tall such that it is a boy, is 4%, that is 4 by 100, and probability of T by G, that is the student selected is over 6 feet tall such that it is a girl, is 1%, that is 1 by 100. Now we carry forward this data. Next, we will see how to find the probability that the student selected is a girl, given that it is selected at random from among all those over 6 feet tall. That means we have to find probability of G by T. And according to Bayes' theorem, probability of G by T can be given by probability of T by G into probability of G upon probability of T by G into probability of G plus probability of T by B into probability of B. We have already calculated all these probabilities. Let us substitute those probabilities over here. Probability of T by G is 1 by 100. Probability of G is 3 by 5. So your numerator will be 1 by 100 into 3 by 5. Same figure will come over here. Plus probability of T by B is 4 by 100 into probability of B is 2 by 5. You can easily cancel out this 1 by 100 and 1 by 5. So we will left with 3 upon 3 plus 4 into 2. Further simplifying which we get probability of G by T as 3 by 11. So the probability that the student is a girl such that it is selected from all those students who are over 6 feet tall is 3 by 11. I hope guys you understood this example. Now let us proceed for next example. Let me read out this example for you. A factory production line is manufacturing tennis balls using 3 machines A, B and C. Of the total output, machine A is responsible for 25%, machine B for 35% and machine C for the rest, that is 40%. It is known from previous experience with the machine that 5% of the output from machine A is defective, 4% from machine B and 2% from machine C. A ball is chosen at random from the production line and found to be defective. We are asked to find the probability that it came from machine A. Guys, you can pause the video and read this question once again for better understanding. Let us first understand this example. Here, experiment is to select a ball from production line. And since there are 3 machines in the production line, A, B and C, this ball selected is manufactured from any one of these 3 machines A, B and C. Therefore, sample space is partitioned into 3 parts A, B and C. Given that the ball chosen from the production line is defective and we know that each of these machines A, B and C produce some amount of balls defective. Therefore, event D will intersect each of these events A, B and C. Then to find the probability that the ball selected is manufactured in machine A, we have to find probability of A by D. This can be done using Bayes theorem. So to write the solution formally, we first note down the required events. Let ABC be the events that the ball chosen was manufactured in machine A, B and C respectively. Note that it is given that of the total outcome, machine A is responsible for 25%, machine B for 35% and machine C for the rest, that is 40%. Then probability of A, that is the ball chosen was manufactured from machine A, is 25%, that is 25 by 100, that is 0.25. Then probability of B, that is the ball chosen was manufactured from machine B, is 35%, that is 0.35. And similarly, probability of C will be 40%, that is 0.40. Next, we define event D, denoting the ball selected is defective. As it is given that 5% of the output from machine A, 4% from machine B and 2% from machine C is defective. Therefore, probability of D by A, that is the ball selected is defective, given that it is output of machine A, is 5%, that is 0.05. Similarly, probability of D by B, that is probability that the ball selected is defective, given that it is output of machine B, is 4%, that is 0.04. And similarly, probability of D by C will be 2%, that is 0.02. Let us carry forward all these probabilities. As we have to find the probability that the ball selected is manufactured in machine A, given that the ball selected is defective, it means that we have to find probability of A by D. According to Bayes' theorem, A by D's probability can be given by probability of D by A into probability of A upon probability of D by A into probability of A plus probability of D by B into probability of B plus probability of D by C into probability of C. Substituting all these values, we get probability of A by D as 0.362. Guys, you can pause this video and check this calculation. So we have found the probability that the ball selected is manufactured in machine A such that it is a defective ball is equal to 0.362. I hope guys you understood this example. Now we proceed for next example. Let me read out this example for you. An engineering company advertises a job in 3 newspapers, A, B and C. It is known that these paper attracts undergraduate engineering readerships in the proportion 2:3:1. The probabilities that an engineering undergraduate sees and replies to the job advertisement in the paper are 0.002, 0.001 and 0.005 respectively. Assume that the undergraduate sees only one job advertisement. If the engineering company receives only one reply to its advertisement, calculate the probability that the applicant has seen the job advertisement in place A. Guys, I once again request you to pause the video and read and understand this question once again. Let me proceed for solution. First of all, we define the required events. Let A, B, C be the events that the applicant has seen advertisement in the newspapers respectively A, B and C. Note that these papers attracts undergraduate engineering readerships in the proportion 2:3:1. That means 2 plus 3 plus 1, that is out of 6 readers, 2 are reader of newspaper A, 3 are of B and 1 is of newspaper C. Therefore, probability of A, that is the applicant has seen the advertisement in the newspaper A, is 2 out of 6, that is 2 by 6. Similarly, probability of B, that is the applicant has seen the advertisement in newspaper B, is 3 out of 6, that is 3 by 6. Similarly, probability of C can be given by 1 by 6. Now let us define event J. It denotes that the reader has applied for the job. It is given that the probabilities that an engineering undergraduate sees and replies to the job advertisement in these papers is respectively 0.002, 0.001 and 0.005. Then probability of J by A, that is reader has applied for the job, given that he has seen the advertisement in newspaper A, is 0.002. Probability of J by B, that is reader has applied for the job, given that he has seen the advertisement in newspaper B, is 0.001 and similarly probability of J by C is 0.005. Let us carry forward all these probabilities. Next, we have to find the probability that the applicant has seen the job advertisement in newspaper A, given that the engineering company receives only one reply to its advertisement. That means we have to find probability of A by J. And according to Bayes' theorem, probability of A by J can be given by probability of J by A into probability of A upon probability of J by A into probability of A plus probability of J by B into probability of B plus probability of J by C into probability of C. Substituting values of all these probabilities over here, we get probability of A by J as 1 by 3. Guys, you can pause the video and check this calculation using calculator. Therefore, now we can say that the probability that the applicant has seen the job advertisement in newspaper A, given that the engineering company receives only one reply to its advertisement, is 1 by 3. I hope guys you understood this answer. Now it is your turn to solve some examples. Below are some examples with their solutions as well as some hints. You can pause the video and take the screenshot of these examples and try to solve these examples. This is example number 2 and example number 3. I hope guys you will solve these examples and you will write me in comment box whether you got these answers or not. In my next video, I will come up with more such interesting topics. Till then, keep watching my videos. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.